Okay. Yeah, so good afternoon again to everyone. We are resuming AI for developers training. So I'm starting with the course outlook. We have done up to week 6 so far, even though we took more than 6 weeks. So being in week 6 doesn't mean this is a 6 week. In some situations, we probably spent like more than a week, because of the scope of what we had to cover, especially the hands-on sessions. But we have done the AI-assisted development workflows where we learned how to use all the tools. We have looked at the kind of tools used for productivity. We looked at how to leverage on SDKs uh, to access LLMs that are hosted by AI providers. And then we talked extensively about embeddings, about vector databases, semantic search, and RAG. So I hope the whole concept of RAG, we've really gotten it. RAG is like the beginning. So as a developer, RAG is one of the ways that you can extend the capabilities of large language models, because the large language models are trained on data. That data is um, sometimes it may be stale. So for example, I don't know if you've ever had a situation where you ask ChatGPT a question and it tells you that its knowledge extended only till 2024, right? And it cannot answer that, right? So that's just one example. And there are many other such cases. So that is one limitation, for LLMs where, the data is limited. The other thing is the data that you use to train LLMs may not include proprietary data. There's no company that will issue out its proprietary data to you for you to use and train your LLM. So because of that, if you want LLMs to now be very useful, they have to be able to do something with that data. And that's where we now talk about extending. And that's where we now talk about things like the RAG, because the RAG allows you to provide the proprietary data, maybe in a company, in a business, or personal data. You provide it at the point when the query is being made as context, rather than providing it at the point when the model is being trained as training data. So that is additional way to um, kind of supplement and leverage on the capacity and capability of LLMs. But that's not the only way. So this week we are going to look at a couple of other methods, right, where we can extend the capabilities of LLMs, what we call functions, tools, skills, and so on. And then after that, we will go into LangChain. LangChain is a very powerful framework that simplifies a lot of the things that we have been doing. I have deliberately let us do it from scratch so that you know how difficult it is, right? But more importantly, you know what's going on under the hood. Now, with LangChain, a lot of those things will be very easy. LangChain allows you to use large language models to swap them out easily, to add additional features, the things that you can do with large language models. It basically allows you to um, do all of these things we've talked about with less lines of code, because the library, the framework has already taken care of a lot of things. So we'll look at LangChain, and then we'll look at as a designer or a developer, or someone who is building an AI-enabled application, what are the considerations? What are the things that matter? Then we'll look at AI basics. We'll look at front end. We've been doing a lot of back end with Python and Node.js, but at the tail end, we'll go into a bit of front end where we will use JavaScript, right? TypeScript to see how to do stuff. So for those who are not familiar, I will try to make it easy to jump in. I think it's still good to do that, even if you are not planning to specialize in JavaScript or anything, but it's still a good thing to know. And the principles apply. These are principles that apply across the board when it comes. These are programming principles. These are products design and development principles. They're not really tied to any specific um, programming language. Okay. Um, and then we'll look at Mastra. Mastra AI is an agentic framework. It's a framework. It's just like LangChain. It's a framework that allows you to build agents. So all of the things that we were doing manually and so on, right? Mastra provides them and allows you to easily, pull together all of the components to build agents. But it is TypeScript, so it's a front end framework. So we'll look at how to use it to build a few things. And then after that, we'll now talk about how we can integrate Master at the front end and use LangChain at the back end. By the way, LangChain has a JavaScript library. It also has a Python library. So depending on how you want to use it, you can choose to use it. So having said that, today, like I said, we will start with how to extend LLM capabilities with tools. So there's something we call functions or tools. So we're going to, at the end of this week, you should be able to know what a tool means in the context of a large language model or in the context of AI and why LLMs need tools. What are types of tools? A function is one of the things that we call tools, right? So how do you call functions? How do you invoke functions and other tools? And then we'll look at other ways that you can connect your LLM to external data, right? Without having to hard code API calls. So far, we when you want your LLM to access data in the past, you would have to connect to APIs and so on and pull the data if it needs the data for something like what we did with RAGs. Even though with RAGs, we are uploading the data, right? But what if the data is elsewhere and you want the LLM to have access to that data so that it can reason properly around that data? Right. Are you going to always hard code integrations? You don't have to because there are new standards that have been developed recently. What we call MCP, the MCP model. MCP is a specific model context protocol that has been developed by Anthropic. Anthropic is a company that owns Claude, right? But the other companies, the other big AI companies have their own kind of um, counterparts to MCP, right? They have different names, but we'll look at what MCP is and the general idea around it. So that we'll do today. And then when we come back on Friday, we'll look at LangChain. We'll have an introduction to LangChain agent frameworks. Then we'll look at LangChain concepts. Basically, introduction to um, LangChain and how we'll look at how LangChain simplifies so much of the things that we were doing, by ourselves, writing from scratch and so on. And then we'll talk about reasoning patterns, react and plan execute. So this is when we start talking about how you build agents, right? If you want to build an agent, okay? And then we'll look at how you can build a RAG using LangChain and how much easier it is to build a RAG. Some of the things that LangChain would do for us would include things like the chunking that we did, different chunking, you know, um, methods and approaches, and other things like re-indexing and so on, right? And then we'll think about just general principles around designing agentic backends. So let's start with tools, functions, and skills. So yeah, so we had in the last couple of years, right? There was a lot of excitement when we had, large language models. They could store knowledge, they could learn from data that was given to them, right? And they could regurgitate that data or reason around that data. Well, I wouldn't say reasoning per se, but they could generalize. That's the correct terminology. They could generalize from data and tell you things. Those are what large language models do. They tell you things based on data that they are trained on and based on the question you ask them. And the reason why the questions are called prompts rather than query or question is because of how large language models work. Basically, a large language model is what we call a generative model. It generates, it generates a sequence of words or sentences, a sequence of characters, you know, based on training data. But for it to generate something, you need to kind of start it off with, okay, I want you to generate. So think of it this way. You trained a child to mimic and be talking like an adult. So the child learns how to talk like an adult, even though the child doesn't understand what it is saying, but it's just mimicking, right? So you now it's something like you tell the child, okay, if I start a sentence by saying, what is my name? How would this sentence continue? And then the child would mimic it, right? That's what the large language model is. So the first few words you give to it, that's a prompt. That's why it's called a prompt. You are prompting basically the model. You are starting it off, and then it will kind of generate the rest of the sentence. So essentially, what large language model is doing is trying to simulate a conversation, right? Because that's what it's trained to do. It's trained to simulate a conversation with a high level of accuracy. So it's now at the end of the day, it comes up looking smart, but it's basically just simulating, or if two people are discussing on this topic, how would they discuss? What are the things they would say? And it's basically just simulating that. But we see it as knowledge, right? And in a way, that's what it is. Because over time, especially the larger models, they actually begin to have what we call internal representation of what you're teaching them or training them on. They become very good, right, at simulate this simulation in quotes. They become so good that it's like, okay, they're actually exhibiting intelligence. But I wouldn't say they're exhibiting, they're simulating intelligence. That's why they're called AI, artificial intelligence. So LLMs started off that way. You give it a static prompt, right? The prompt is basically kicking it off in that is how the conversation would be. And then, so the early AI apps that use these LLMs were based on static prompts. You give it a prompt, and then you have what we call singleton or chain responses. A singleton is you ask a question, it gives an answer. That's one turn, right? Think of it like a game of chess or draft or checkers. You play your own turn, and then the opponent responds. So a singleton is I play one move and I get a response. So I ask a question and the LLM responds. That's a singleton. But or chain responses. So a chain response is response that, comes in a chain kind of. But that's not enough because now we want AI to do more. Where I'm no more happy, that an AI can just give me an answer. No, it needs to become useful. So we are now moving LLMs from the domain of being able to generate or retrieve. I don't want to say retrieve, it generates, conversations to actually being useful, solving problems, right? And doing stuff. So the modern AI systems now require that LLMs should be able to reason, you know, before responding. But we are now asking more of LLMs. We want them to be able to even have current knowledge, even though they were trained on past data. So how can a model that you trained on past data have current knowledge, right? The only way to do that is to give it access to external data. So we now have LLMs as a core that reasons. So we are now using LLMs as reasoning tools or reasoning engines. And then you bring data to the reasoning engine and ask it to reason about the data. And then we now turn it into not just a single turn, reason about this single data and give me an answer, but iteratively reason. So it now becomes a multi-turn, you know, um, um, I don't want to say device, but that's what it is, where you give it data, right? It looks at you give it a prompt or a request, what you want it to do. It looks at that request. It is now able to do things iteratively in steps, breaking it down to steps and then doing the steps rather than just trying to do everything one shot, which is not really going to be feasible or even practical or even possible. So it will now decide it will first of all break the problem down into what it needs to do. So it's now reasoning. And then when it breaks it down to what it needs to do, it needs to figure out how to do those things. So you need to give it ability to do those things, the ability to take actions, the ability to request information, the ability to access additional data that it needs. And then when it gets all of those things, it can reason more on that additional data and information and the responses from the actions it has taken and decide what the next steps are. So it now becomes more, let me say human in quotes, because it is not just doing a one-shot answer to a question. It's actually breaking down problems, and it is, taking steps to, um, go through them and solve them. So that means that in the last couple of years, 2, 3, 4 years, LLMs have basically evolved from just being um, a generative um, model or engine that just generates knowledge to becoming a reasoning engine that you can embed inside a larger software system. And that's where we, as the AI developers, the AI engineers, will be able to we'll be able to add the additional things that it needs, that additional enablers for it to become useful to everyone. So all of these things then are now encapsulated under tools, functions, and so on. So tools and functions are very crucial for LLMs. They bridge the gap between LLM being just a text generation engine to becoming something that solves real world problems and takes actions. Because anything, yeah, having a text generation engine that gives you knowledge is good, but people want more. We want it to solve our problem. Don't just tell me, right? So with tools and functions, you give models the ability to access real-time data. So remember, you train these models, or these models were trained on previous data, past data, to be able to generalize. But we also want it to be able to pull things as they are currently. So you have to give access to real-time data. To perform complex calculations, it's not everything that a large language model can do, right? For example, in recent times, they've tried to use large language models to make it play chess. It plays terribly. It plays chess terribly. It doesn't even understand, even though they have tried to fine tune all of that. Um, Doing complex calculations is also difficult because this is a language model. You trained it to understand languages, not to do complex calculations. In fact, there was a time for those who have been using ChatGPT right from the early days, if you ask ChatGPT to do some maths, it will get it wrong. Or if you ask it to count the number of bees in strawberry, it's a very good example. That strawberry thing. How many bees are there, or how many R's are there in strawberry? Right? How many R's are there in strawberry? And some LLMs will say 3, some will say 5, some will say 10. So um that's they've eventually fixed it, right? But it was already clear that as a large language model, it couldn't even count. But there was explanation around that it was due to tokenization. Tokenization, one of the R's got missing. So they will always tell you that there are 3 R's in strawberry. But we know that there are 4 R's in strawberry. Or maybe I'm wrong. Maybe I'm an LLM also. Okay, so anyway, so for LLMs to be able to do things, execute specific tasks, like booking flights, sending emails, and so on, you have to give it, abilities, right? So these abilities are what we call functions or tools. So they have knowledge, but we now add abilities. So these abilities now enable LLMs to go from simply knowing things, which they get from the training data, to doing things which they get from these abilities that you give to them, so that they can create so we can create, we'll be able to create dynamic intelligent agents which we need to be able to do in order to solve multi-step workflows. And this multi-step workflow is when LLMs become really useful, right? So LLMs are no longer just chatbots that you just chat with them and get information or ask questions and so on, but they have now become components in intelligent tool-driven systems. And we have seen that already. Like if you have GitHub Copilot now in your VS Code, you are going to see what we call agentic mode. You can give it stuff. What I would like, um, I think I showed that. What I would like you to do is ask agentic mode to generate code for you and just look at the reasoning that happens. You'll be amazed and you'll be asking yourself, how was this done? How was this programmed? How was this built? Right? We will be able to see how some of those things are achieved and you'll be able to do some of them yourself. So that's the background behind, the history of how we have moved from just LLMs being knowledge engines to becoming reasoning agents to becoming active agents that can do a lot of things. But it started off by solving this basic limitation. Why do LLMs need tools, functions, and skills? I think we've gone through this already. The main limitation is that one, LLMs don't have access to real-time data because they were trained on past data, even though they can generalize. But if you ask an LLM who is the current president of the United States, and he was trained on 2023 data, right? It won't know because as of 2023, there was no president. Okay, there was a president, but the president at 2023 is different from the president today, right? The president in 2024 is different from the president today. So if they were trained up to December 2024 data, right, the answer will be wrong. There's no way there's no generalization that can allow you to predict who is the president. Even though, well, as at 2024, the LLM would have known who are contesting. If you were training it up to 2024 data, it will know who is contesting. And it can even look at the polls and tell you, okay, based on the polls, I can predict that it's either this person or that person, that came out successful. But it doesn't really know who came out successful, right? So you will not be able to predict. So if you now ask the question, who is the president of the United States, or who is the president of Nigeria today, right? You will likely get a wrong answer. So in such questions, right, you need to give the LLM access to current real-time data. Basically, allow it to browse the web and, you know, search for that information. Then the other thing is private data that is in your own private server or a lot of companies have private data in their private servers, right? You are not going to, the LLM is not going to have access to that. So the other thing LLMs cannot do, in spite of everything, they cannot query databases, they cannot call APIs, they cannot execute code, right? And then the responses from the LLMs are probabilistic. Probabilistic because it's basically doing predictions, right? It's probabilistic, it's not sure. It's always, oh, the probability I have 90% confidence that this thing I'm saying is correct. That's probabilistic, right? It's non-deterministic. Non-deterministic means sometimes it can be random, okay? And it's hard to verify. So you cannot use LLMs to solve problem in that manner. So what do? We provide tools. So the tools now allow the LLM to take deterministic action, make API calls, make database queries. It allows the LLM to have access to internal systems, data in private networks, right? Live data, real-time data, enterprise knowledge, right? So it enables the LLM to have the hybrid intelligence. The hybrid intelligence is that you now use the LLM's own reasoning and combine it with the code that you're writing as a developer for execution. So a tool or a function is basically code that you write that does a very specific thing, which the LLM would otherwise not be able to do. That's what a function is. And that definition of function is now extended to what we call tools. So a tool is what is a general ability that you give to the LLM. So it's not just a function call, but being able to call out to an API or run a database query and so on. So LLMs think, but the tools act. So a real system needs both. So now what's the difference between a tool and a function and a skill? in the context of AI and LLMs. So like I said, a function is a structured interface that the LLM can call, just like a function that you write in your code. And in most cases, a function is actually code that you write. But when you finish writing that code, you still need to send some metadata about that function to the LLM so that the LLM can know what that function does and know when it needs to use it. So the function tells the model what inputs are allowed. So just like a function definition, a parameter function definition, that's what it is. It will tell the model what inputs are allowed and what outputs are expected. So with that, the LLM is able to decide what the function is used for and is able to figure out when it needs to call that function based on whatever, right? So some of the characteristics of the functions is that it's JSON. Most times we have to have a format to encode the data. It has to be machine data encoded. So it's JSON or some other kind of schema based, right? There's no business logic in functions, right? It just does a single thing. Um, then from the standpoint of LLMs, the function definition is a contract, right? A contract, think of it like an interface. An interface is something that says, if you want to call this function, these are the arguments you must provide. That's a contract. It's basically saying, for you to use me, this is what you have to give to me. And after you have given it to me, this is what I'll give back to you. That's a contract. It does not go into implementation details, like this is how I'm actually implementing this function. And it does not actually execute the function. So that's the other thing. In the context of an LLM, the metadata that you are sending or the definition of function in the context of an LLM doesn't actually execute the function. It just tells the LLM what that function does. And then the LLM will now do it. But the actual execution of the function will still be done by you who is writing the code. Okay. So this is an example of a function. This is a standard function definition that we have. It says it is a function called get user profile. The argument is user ID and the argument type is a string and it returns a user object, right? So it's a contract. That's what and it means. An interface, like for those of us who are doing object-oriented programming, an interface, that's what it is, or a function signature, right? So that's what a function is. A tool is now a broader definition of things that can be executed. So a function is actually a tool, but a tool is more than a function. A tool is a higher classification and function falls under it. So some of the things that you can do with tools, if tool performs real actions, it does data access. So some of the things, characteristics of tools is it calls API, right? Queries databases, run codes, right? It runs code either in the command line or in an environment, and then it returns those concrete results. So a function is a tool, right? That is how you understand it. And a tool is a group or a class of things that includes functions, includes API access, includes database access, and all of that. So an example is a Python function that queries a database or calls a REST API. So that's a tool. A skill, on the other hand, is a reusable or higher level capability. A skill speaks more to how to solve a particular class of problems rather than actually solving it. So a skill, there are actually several definitions of skills, but in the context of machine learning, training the model, you can train a model until it learns a skill. A skill is, in that context, is something the model has learned to be able to do. It has learned how to use tools and functions, right? But in the context of AI programming or AI development, right, a skill encapsulates like how you solve a class of problems and you basically tell the large language model, how it's the how to do stuff basically. And it's often domain specific, right? And the skill can be reusable across agents. So example of a skill will be summarize a legal document using a RAG plus citation checking. So this is something that you give. It's not really the prompt itself, but it learns how to do it. Okay, so we are going to look at examples that will help. So the first thing I want to do, I'm going to go through calling a function, right? And there are multiple. We'll go through calling a function, then we'll go through. We'll come back to this to look at tool invocation, lifecycle, and other things. Now, I'm going to do 3 examples how you can call a function using prompt chaining. We already did prompt chaining, so that kind of preps us for this, right? So typically, the process for function calling is you define the functions or the functions already exist, right, locally on your system. Then you create a mechanism that allows the large language model to know all the functions that are available, right? And then after that, depending on the functions that are available that it knows about, you can then ask it to perform some tasks and it will decide whether it needs a function or not based on the task. And if it needs a function, the response the large language model will give to you will include that it needs a function call, right? And then you will pass that response and run the function and give it the result from that function call, and it will take that result and complete the process and then give you the final answer. So this is what we are going to do. So functions are normally defined using a JSON schema. So we're going to look at that with strict input and output contracts. So like I said, the input is this is what you should provide for this function call to work. And this is the answer or result that you will get when you provide this input. The JSON schema matters because it enforces type safety. So when we have moved away from the realm of large language models and reasoning and probabilistic and non-deterministic thinking into the realm of code execution, where things have to be very specific, there has to be type safety and all of that. Otherwise, your system will crash or you have errors, or even worse, people can even hack into your system, right? If you don't enforce it. This is where the JSON schema comes in and acts as a kind of gatekeeper, if I may use that, to enforce several things. So you can enforce type safety in the JSON schema by saying only give this in this format, right? Then ensure that required fields are provided. Then the JSON schema also ensures that hallucinated parameters are reduced. You don't have the LLM generating, weird or fake parameters, right? And it also makes the LLM outputs to be machine readable because your code is not an LLM. Your compiler or whatever is not an LLM. It will not be able to reason about, you know, um, parameters or arguments that are not very clear and specific, right? So the JSON schema forces that and ensures that whatever comes from the LLM is machine readable. You now plug that, you pass it, you do validation on it, just like any input from any other human being. So just think of an LLM as a regular user that is using your code, right? You are the one that wrote the function, and you're asking the user to decide the function that he wants to call, and also give you the arguments that you pass into the function. So you have to, ensure that all of that is machine readable. So the conceptual flow, like I said, is as a developer, you first of all define the function schema. The function schema is different from the function. The function, either you wrote it or it already exists, right? But you have to define the schema. You now send that schema to the LLM in a prompt. Then the LLM will decide whether it needs to call the function or not. It's not all the time it will need to call the function because the question you're asking the LLM may not require a function call. So it will just respond. And then the arguments and everything you have specified, it should return it as JSON, right? And then it is not the LLM that will execute the function. It is not even the LLM provider. The function will not be executed on their server. It is you, your own application that you are writing that will execute that function. And then the results from that function will be sent back to the LLM to complete its reasoning and give you the final answer. So we are going to do that now. So I already have a bunch of notebooks. I have Jupyter notebooks just to make it easier. I also have a VS Code, which I will show for JavaScript folks, so that you can also see how to do the same thing in JavaScript. So let me just pull that up quickly. I'm going to explain this and I'm going to share this. So I'm going to use, there are three methods we will use for function calling to demo function calling. The first method, we will just use straightforward prompt chaining, right? The reason why is so that we will understand that it is actually a prompt chain that we are doing, right? So that we will not think that it's some magic, right? That we cannot do. Um, yeah, so there's a question here. Does JSON support user-defined types? The types actually will, since you're using a schema, the JSON is just a transport mechanism. It's not like the JSON itself is going to enforce the typing, but the JSON allows you to define the return values, the type that should be, and all of that, right? That's what. So what JSON actually does is it's a transport mechanism that allows you to information. So like I said, there are four steps. The first is defining the schema. So if you look at this, right, we start first of all, let's assume that you have an LLM and you want that LLM to be able to search your database and get the information for a user, based on the user ID. That's something an LLM will never be able to do, right? Because the database is your own, right? It was never trained on that data, so it will never be able to have access to that information, right? So you can define a function. So here we are just using an arbitrary way of defining function. Like we said, a function schema. So I came up with this, right? This is just a very simple. There are now standards, like OpenAI has standards, and then we have MCP standards and so on, which we'll look at later on. But I don't want to go into all of that. So the first thing is you define this. So this is simple JSON, right? It's not really JSON, though it's JavaScript. It's a dictionary. This is a Python dictionary, right? But it's easy to see this as JSON because it's more or less similar. So you can see I have defined three functions here. This is a function schema. The first function is called get user profile. The second one is called search documents. The third one is called get current temperature. So these are all functions I have already defined in my, exist in my system. I have defined it, right? Or they exist before, maybe from the compiler or even in the programming language. So this first one will fetch a user profile. So we have to tell the LLM what this function does. That's what this description field does. It tells the LLM that this function will fetch a user profile by user ID. Then this second is to tell the LLM that these are the parameters that the function must be supplied with. So one is the user ID you need to specify, and the type is string. You see, so we have used JSON, or in this case, the dictionary, which will be turned to JSON anyway, to encode this additional contract. So this is what we mean by the contract. The contract is basically saying that when you are calling this function get user profile, you must provide a parameter, and that parameter is called user ID, and that parameter must be a string format. Okay, so that's the first function. Simple schema we've used to define it. The second function, search documents. So this is, you're now telling the LLM that if you want to search internal documents by a query, right, you can use this function called search documents, right? And based on this function, right, these are the parameters it must specify. It must specify the query, and that query must be a string. So again, this is another function definition, basically in the schema. Then another one, get current temperature. This is again the name of the function. Description. This tells again, like I said, the LLM that this function, if you want to get the current temperature in a given location, and the parameters you must specify location. That's the name of parameter, and it must be a string. So with this, we have defined the uh, metadata, the function schema. Now, the next thing, this is a contract, right? The most important part, where you now specify to the LLM, you can see that it is actually a prompt, right? It is a prompt. So one thing you will learn is that anytime you want to interact or communicate with an LLM, it is a prompt, nothing more, nothing less. You have to write a prompt. But it's how you put together that prompt. So in this prompt, we say the prompt is you are an AI router. Your job is to decide, and this is a system prompt. So we're using a system prompt for this, right? Instead of, when we're doing prompt chaining last time, we were kind of chaining prompts into user prompts, right? So we take the previous result from the previous one, we'll put it into the prompt for the next one, and we keep going like that. But in this case, we make it a system prompt. And the reason why is because this is always going to be the case. It's always going to be true for every single interaction with that LLM. So we can just make it a system prompt. A system prompt is a prompt that will always be there. So you don't need to always remember, right? The LLM will remember because you have put it as a system prompt. So the system prompt is you are telling the LLM you're an AI router. Your job is to decide whether a function should be called. Then you give it the list of available functions. So you can see this function. This is the name of this that I put in here, right? So you give it the available functions, and then you also continue to specify the rules. If a function is needed, return only valid JSON. This is very important part of the prompt, because if not, the LLM will go crazy and start giving you all kinds of useless rubbish. So this is one thing you need to learn with LLMs. You need to constrain it and tell it exactly what to do. Think of it, like I said, as a small child that you're giving instructions. It doesn't know what to do, but anything you tell it to do, it can do, right? So in this case, we are telling it if it has reasoned about the user prompt you are giving it and a function is needed, then it should only return the valid JSON. And then you now specify the format of that valid JSON. And this is the format, right? You specify name, which is a function name. So this function name will come from these functions you had given to it before. That's why if you don't give it a list of functions, it won't work, right? And in the functions, remember, it was a schema where you have specified the function names in this way. It knows how to reason about this, even though you did not tell it the schema of this JSON thing. Because I know somebody will ask me, okay, does it know that this is what is a function name rather than this one? One other thing we need to know is some of these, well, not some, most, if not all, have been trained with this thing. So they kind of understand this, right? Maybe an LM that you haven't well trained may not be able to know that, okay, I should extract this. This is the one that is a function name. But then it sees that that's the only thing that is different, right? For these other ones that are the same. So anyway, it's able to figure out what the function name is from this, right? So it's going to inject that. So you are telling it where if you want a function call, send this format, and this JSON format specify the name, and the value of the name should be the function that you want me to call. And then arguments, send me another JSON object. This dot 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 means figure it out for yourself. And then tell me all the things that it needs, right? Then you give it additional rules. Do not include any explanations. Do not include markdown, right? If no function is needed, just return this, right? Return name is null, and then return text response. So this text response will be where it actually has the answer. So it's still going to give you a JSON response, right? With this answer. So that is a prompt. So I'm going to load this up. Then we will now have an LLM call. It's actually not a simulated LLM call. This is a real LLM call. So we have an LLM call. I'm going to do this with Google Gen AI, and I'm also going to do this with okay, I'm going to do this with just Google Gen AI. But you can do this with any other one. It's not, you can use it open router, open any model. Most models will be able to do this, right? Oh, that reminds me, I need to set up my .env and put in the key. So let me do that quickly. So I'm going to load the Gemini API key. So this is what we have been doing all this while, where we will create a Gen AI client. Okay. Of course, we load .env to load the secret from here, the key. And then I wrote this function. Now, I'm actually going to take this out because this is not even needed. Now, it will give us a text, right? After you call the Gemini Flash, it's going to give us a response text. That response text is going to contain either what we ask it to do, or it will tell us it needs a function call. And I'm going to demo it shortly. Let me just put in my key right now. So give me a second. Let me put in my key. Okay, so I've put in my key, right? Uh, okay, it's been saved. So now, by the time I run load.env, I run this code block. Um, this should set it up, right? So I've set up the function that calls the LLM. And you can see what I did. The system prompt is there as a parameter and the user prompt. So this system prompt is always going to be the system prompt I created, because this system prompt is what will tell the LLM that it should do a function call if it needs. So we always need to pass in the system prompt. And with Gemini, this is how you combine system prompt with user prompt. For each of them, there are different ways, so you need to figure that out, right? For OpenAI, there's a role called system, which you will use to pass the system prompt. So for each of them, each of the SDKs have slightly different ways of injecting a system prompt and the user prompt. But in this case, you see that I use this config attribute, or this config argument. I say, okay, system instruction. So we use a system instruction key to specify the system prompt, which will be passed in here. And then the contents is where I pass in the user prompt, and it's passed as a list. This means we can put multiple prompts and just chain it instead of just a single prompt. So with that, I can do call LLM system prompt. I could actually simplify this by not even specifying system prompt. I could just remove this, right? Maybe I should do that just to simplify things, because I'm not even going to change that. So let me just directly put the system prompt in directly instead of having to do that. So I'll just put that in here. Okay, so I don't need to pass it in as a parameter. So I'm going to rerun this. So now we have the functions defined, right? We have the system prompt defined, and then we now have the function that will call the LLM and inject the system prompt. So let's now start with something that doesn't require a function. So tell me something nice, right? Tell me something nice doesn't require a function call. So what does it give me? Let me put this in a print and see if it is going to make it look better. So you can see it structures this properly. You can see it returns a JSON format. Compare this JSON format now, right, with the instruction I gave to it. I gave it the two options. If it needs a function call, then you should give name, the function name, and argument. But if it doesn't need a function call, you should say that name is no, and then return the actual value as text response. Now look at what it gives me. It actually gives me that. So it has followed that contract that I gave to it. I said, always follow this pattern. And this is it. So you can see you are amazing and capable of great things. Did it ask for a function call? No. Simply because I did not ask it. Now, if you now ask it for something that requires a function call, it will then tell you that it needs a function call. So let me modify this because I have removed this system from, so I'll just remove this completely. We don't need to, keep injecting that. So here we are saying get the profile for user 123, right? Remember there are three function calls that we defined. We have a function called to get user profile, search document, and get current temperature. So I'm going to try, questions that require that. So the first one is this: get user profile for user 123. If I run this, and I want to print it, so let me print it so that it will also format it properly. So if you look at the response, you can now see that it actually gave me that name is get user profile and arguments. Can you see? It now tells, because it didn't give me name as null, it means it has reasoned about this prompt and it has seen that there is need for a function call. So it tells you the name of the function to call. Not only that, it's also able to reason and tell you the arguments that the user ID is 123. Now you could say, okay, maybe because how I formatted this prompt, it looks it's so neat and everything. Let's try something that is not, call LLM. I want to find out information on the user with user with well, by the time you even say with ID this um okay, this is a simple one. So let's do that again. It's still going to tell us that you need a function call and it's able to extract this. So this is one of the powers of LLM, being able to now ask it to give you structured data. So this is the second part. Now that it has, remember the LLM cannot call the function. It cannot actually execute the function. It just tells you that it needs a function call. And it tells you the, um, metadata that you need for the function call. The next thing is for you to now do the function call. And this is where we now come to the execution part. So if you didn't have those functions existing, of course, you have to create them. So I created them here, but sometimes the function may be a function that already exists or, things already exist. So I created this. So you have this dummy implementation I didn't bother about. Then there's one other thing we do here, right? There are many ways you can now convert this metadata that this request that the LLM into an actual function call. You could just say in some programming languages, you can actually just directly eval. You can use eval, but I tell you, do not try that. It is not safe because you do not have control over what the LLM will do. Do not directly eval or evaluate the code or the response that comes from an LLM. There's something we call prompt injection attack, where an outsider can actually include some things that would change the response. The LLM will read those things as additional prompt and will change the response. So if you just give LLM free access to your system without controlling what it does, people can have prompt injection attack, or even the LLM can decide to become bad. Maybe the day when AI decides to become wicked and they will run and install viruses. In fact, the LLM doesn't need to become wicked to install virus on your system. If it thinks that installing a virus will be one way to solve world hunger, it will install the virus in your system. You understand? So this is the point where it is very, very key that you do not do things like eval or even is callable. Because if you say, like in Python, there's a function called is callable where you could have done something like this. You could have done something like this. If is callable, I can't remember whether it's callable or callable, right? If it's callable, you now specify. So remember, we've gotten a response. Okay, I did not actually assign this to anything, right? So let's now try some experiment. I take this, right? I assign it to a value, a response equals this, right? So it's going to give me this same thing, name and this. So response name is going to be get user profile. So if I now say if it's callable, response name, right? Then because it's callable, yeah, okay, let me just call it now. So response name. This will still work, by the way, right? Response arguments, right? It's going to do that. I don't know why this is not, okay, so maybe that is not what it is. Um, maybe that's not what it is. But there are constructs like this, right, that allow you to check if it is a function. The other thing is you could also say if type of this. So this is another way of saying it. If the type is function, and if the type is a function, just run it, right? It will run it. Um, maybe I didn't. Anyway, I'm not going to dwell on this, right? Get. I'm not going to dwell on this, but what I'm just trying to say is, it's just to let you know that this kind of, so I don't know why this didn't work. Let's do some. I probably have missed something. Oh, it's a type. Okay, so I should say function rather than this, right? I don't know if that will work. Okay, string indices must be integers. Uh, okay. This is a string actually, but I don't know why that is. So, but every programming language gives you the ability to, oh, there, okay. This is Python. So if a programming language gives you the ability to do like, okay, check if this function exists or check if this is a function and then just run the function. I don't also recommend that approach. I'm actually going to come back to look at this, but I don't want to drag this. I'm probably missing one small thing here, which is not immediately apparent to me why it is talking about string indices must be integers. Oh, I think I know. I did not JSON parse. I need to JSON parse this. Okay, yeah, I needed to JSON parse it. Okay, so yeah. Um, so response equals JSON dot loads. I needed to JSON parse it. Um, yeah, I forgot. So because this is a prompt thing, and well, this happens, right? It happens. It happens often enough. Because this is a JSON string, I was trying to go into the string without first of all passing it first. Um, let's go back to what I had before. Yeah, so what this will do is it actually is going to call that function. I can even print that response and you will see it. Um, but this is not safe if type equals function. This is not safe because what happens in this case is that um, what happens is that you may have functions that actually exist, but they're dangerous. And you're essentially giving this LLM the full power to go out and call out, that function, which is not a very good thing to do, right? So I would not recommend it. So a better option is to have a registry of functions that the LLM is allowed to call. And then in that registry of functions, that the LLM is allowed to call, you now pull out, check if the one that the LLM is asking for is in that registry. And once you do that, then you are safer. Why is that safer? Because simply because the the you have limited the range or the number of functions or the particular functions that the LLM can um, call, basically, right? And that's really the simplicity of it. So I'll come back to this, but I wanted to make a point here, but it seems I'm not getting the right thing to do there. So let's move on. So here, instead, the better option to do, like I said, call this like a function registry, where we say we map the names of function. This is the name that is in the function schema that we sent to the LLM, right? So we map that to the actual function that exists, right? So we map that to this. And so any function that is not in this function registry, we will not call it. And that's simply how that works. Okay, so let me initialize the function registry and then import. Okay, so yeah, I need to remove the system prompt because I have modified that. JSON had already been imported. So we will now try this, and you can see the logic here. It says if it is none, that means it doesn't need a function call. So you are just going to print that, you print the text response. But if it is not none, that means it needs a function call. So you now check inside the function registry and find the one that has that name that is specified. And then you call that function, you assign it to function, you call that function, and you spread out the parameters and pass it in, right? So for this one that we say get the profile for user 123, right? It actually gives us a result. We can now print this result because I did not print it here, but we can still print it. And you see that this result is the result of a function call, basically. So we have taken this request from the LLM for specific information. We pass it through the function implementation, and it gives us the result. So after this is the second step. So we are talking of 3 steps. The first step is define your function schema, prompt, set up your system prompt, and send that into the LLM. So each time you call the LLM, that system prompt has to be there. And then whatever you're asking the LLM to do, if it needs a function call, you get the results, you inspect and check whether it needs a function call. If it doesn't need a function call, you just send the response as is. But if it needs a function call, then you extract the metadata for the function call, including the function itself, and then the arguments. And then you execute the function call. So you're executing the function call in your own environment, in your application environment. So the next step is you will now send the result of that function call back to the LLM, right? So that it can then complete the process with it. And the way to do that is, in order to maintain the context, you have to keep the previous conversation that you have, right? And send as well. So we now have a follow-up prompt that says the function, right, return the following result. And this result, we have to again JSON encode it back, right? So from an object into a JSON string. Then we now call the LLM. This time around, there's no system prompt here, but it doesn't really matter. And then you print. So when we do this, you will see that it's actually going to return our answer. Here's the user profile information, right? Even if you note here, you find that the initial prompt, I didn't pass it in. It kind of retains the memory, so it's able to give you this. And this is just the power of function calling. So already this, if you think about it, you see how much it has opened the vista of the power of LLMs. Think of what you can do with this, right? You can now have LLMs do stuff for you. And that was the beginning of the whole agentic stuff. Because now LLM is no more just giving you answers, right? You can now basically turn those answers into executable action. And think about if you iterate over that, right? So then the other things you can do, of course, you have to do error handling. So if, for example, um, you do a function call and maybe either the parameters or the arguments that the LLM sent are wrong, you need to do proper error handling. I didn't bother to do all of that here, but those are some of the things you have to do. So you see, you have to put in a try block with exception handling. And if there's an error, then you give a good error. Some of the things that we talk about, some of the ways to handle errors would be ask the LLM again, try again. There's something called retries. So if it failed, maybe you didn't get it very well, you tell it to try again. That you send it the error message and you tell it to try again and so on. Then there are other things you could do. For example, when we were doing our JSON parse, we extracted the JSON from the string version of it. We extracted the object from a string JSON representation. I did not put in a try block because sometimes the LLM can hallucinate and give you a malformed JSON. So you have to also safeguard against that. So that's why it is good practice to put your JSON extraction in a try block. If there is an error, then you again do a retry. You can still take the error message and send it back to the LLM and tell it, okay, this is the error message when we're trying to decode your JSON. Okay, try again. So this way you can move from an LLM that can hallucinate, an LLM that can make errors and that can do all kinds of things, right? To ensuring that the LLM is stable, robust, and reliable. Because you have error handling and then you have retrying. So if it makes an error, you tell it what the error is. You tell it to retry. That is where it becomes more useful in the real world. Because in the real world, we don't want things that are unstable, that make mistakes, and you have errors all over the place. And LLMs definitely inherently have all of this. So you need to be able to handle those errors and end up with a very robust and stable, you know, product or system or agent. Well, that's what we call it now, right? So by the time you've done all of this, it becomes an agent. So these are the key takeaways. First of all, calling is a way to enforce discipline, right? In the prompt, the system prompt. Schema enforcement. Enforce the schema so that the LLM will give you back exactly what you want. And then control the flow, right? So this is what we have just done with um, raw manual prompt chaining. All of these frameworks now automate it, LangChain and so on. We're going to look at how to do it with SDKs next. We'll use OpenAI Client SDK that allows function calling or tool calling generically. Initially, it started off with function calling, but we've generalized it to tool calling. So the function call API is kind of deprecated, it's not used anymore. So we're just going to use the tool calling API. So but the main thing is, and the main reason why I did all of this, for you to understand how function calling works. So it helps you think about it, reason about it properly. And if you need to do any kind of modifications or whatever, right, you know exactly what to do. So now, having done that, I will do exactly the same thing with OpenAI SDK, right? So use the function, still the same function calling using OpenAI style. Now here we are calling it tools, right? In tools again is a list, just like when we're doing it manually using prompt chaining, right? We define functions, we define it as a dictionary, name of the function and all of that. But OpenAI has initiated and it's been adopted now across the board, where you can define a function or a tool schema. a tools schema, right? So you define a tool schema. So I'm going to define those same functions using a tool schema. And a tool schema is basically a list of tools. In each tool, you first of all define what type of tool it is, whether it's a function. There are other types of tools. There are API calls, there are other things, right? But for now, we're just talking about functions. So you define this tool that the type, it is a function. So because it is a function, you have to specify the function itself. So you have to define the metadata for the function, and that comes under this function key. And then here you now define that metadata. So the name, you're now telling that this is the name of the function, and the name of the function is get user profile. The description is the same as what we had before. It tells the LLM what this function does. And then you have the parameters, which is more or less the same as what we had before. It tells you the parameters that this function will take. So the first one, you specify the type of the parameters. Type is object. So where the parameters is an object. And then the properties tell you specifically which parameters that you're passing in. And you will see it here. There's only one parameter that we have defined here, the user ID, right? And then the user ID, you specify what type it is. The type, it is a string. And it also has a description so that it could help the LLM to reason about, what the user ID means. So that's properties. Then the OpenAI schema also has an additional field here when you're defining parameters to specify which of the parameters are required so that the LLM will ensure that all required parameters are provided. Otherwise, the function call, of course, will fail. So you specify the required parameters. It's actually a list, and you put the names of the parameters in that list in quotes. All the names here must match the ones defined here. You cannot put a parameter that you did not define under properties. So we've defined one function, and it's called get user profile. We now define a second function, right? And I call it get local weather, right? It gets the current weather in a given location. Okay. And of course, you have to specify the parameters, type of the parameters object. This is kind of standard. And then the properties, the actual parameters themselves. So you have location, which is the location where you want to get the weather from. The type of location is string. You give a description. So the LLM knows that, yeah, it should provide the city and state, example, San Francisco in California. And then again, just like the previous one, you have to specify which of these parameters are required. So location is required. So this is a schema following the OpenAI standard or OpenAI style. So I define it. I have defined two functions or two tools rather. Both tools are functions. I put in these tools variable. So now we will now call the OpenAI. So in calling OpenAI, we're actually going to just pass in this thing. We don't need a system prompt here because the OpenAI SDK will know how to inject this into its own system prompt. So I don't need to do any system prompt. I only need to tell it, here are some tools, right, that the LLM can use if it needs it. And then specify the tool choice. So there's this tool choice, which means auto. There are many other different possible values, but auto means let the LLM decide which tool to choose, okay, or how to choose the tool, rather. There are other ways. You can even pass a function which it will use to choose the tool. Okay. So all of this is standard stuff we've done before. We create an OpenAI. I'm using OpenRouter, even though I'm using an OpenAI SDK, but I'm pulling my model from OpenRouter like I always do. You specify the API keys, which is the OpenRouter. So that reminds me, I have to add the OpenRouter API key here. So I'll do that quickly. Um, Let me put that quickly. So I have my OpenRouter API key here. Okay, so, and then of course, if you are using, you have to specify base URL. Since I'm not using OpenAI, you have to specify the base URL so that you to go to the OpenRouter API endpoint rather than going to the OpenAI API endpoint. I also specify the model I want to use. In this case, I'm using my normal Nemotron 3 Nano 30 billion parameter free. You can always check and get whichever one you want. You can also use a Google Gemini if you want to do that. So with all of this, I now call the endpoint and pass the model name. right? Pass the message. So still the same message. This time I use OpenAI's API where you have to specify role. Role is user. And then I specify the content, which is the prompt itself. Get the profile for user 123. And then, but more importantly, I specify the tools. So from these tools, it will know what tools are available. I've defined two functions as the tools. So with that, I can now call, this is an API call. Now I I can look at the message, right? I pull the message, which is response choices zero message. Now, OpenAI API will give us these two calls. If two calls is an array, it's a list. If it is not empty, it means this is how you now detect that there is a need for a function call or a tool call by checking these two calls list. If it is empty, it means it doesn't need a tool call, so you can just go with what it has. But if it is not empty, then two calls, you have to run through each of the two calls. But for now, I assume because I'm only making one query, there will only be one tool call. So I'm just making an assumption. But in a real world app, you're actually going to loop through all the tool calls and execute each of them. You have to execute each of them, then collect all the results from each tool call execution, and then send that list of results back to the LLM for the secondary part of it. So this is what I did. So with this, it actually does the same thing, right? You get the function selected. This is a function selected, which we get from tool call zero, the first tool call, the function dot name. Then from the first tool call again, tool call zero, the function arguments, you also get all the arguments. So this is basically the same thing as what we got when we were doing it manually. I can print out the whole message, right? So that we will see what is in the whole message. It contains a chat completions object and lots of stuff here, right? This is difficult to see, so maybe that's why I would do it this way. But this one, yeah, it kind of, at least it wraps it so we see, but it's not very well formatted. But at least you will see that content is empty. You see these two calls that I was talking about. The two calls is a list, right, and contains all the two calls. And you see the two calls is what we call a chat completion message function two call. That's one two call. This is the ID of the two call. This is the function. The function is itself another object that contains the arguments for that two call and the name of the function, the tool in this case, which is a function. The type of the tool call, which is a function call, the index. Then of course, it comes with the rest of the stuff, the reasoning. So if you want to know how the LLM reasoned and came about this, you see the reasoning here. You can read about it. The user wants to get the profile, blah, blah. I will not go through this because we don't have much time. So that's the full message, but we are just using these two calls only, this section only, just to extract and detect that that the LLM is asking for a tool call. I could have done the same thing again, right? Without asking for a tool call, and then we'll see what happens. So let's try that, right? I'm basically just doing the same thing, except that this time around, I am not asking for profile ID. I'm doing something like tell. So this is not going to need a tool call, even though I've passed in the tools, right? Okay, so I'm going to now just print the message. Well, I don't want to print it because it will not be readable, so I'll just dump it, right? Response choice is zero message content. Um, okay, maybe I don't want the whole content is the content, but I don't want just the content. I want to see the whole message. So if you do this, right, we'll now see the two calls. So I said, you see, if you take note, in the situation where there was need for a tool call, the content was empty. It couldn't return content because it's not yet finished processing. It is rather just giving you empty content, but it's giving you a list of tool calls. So it tells you, I need to call these tools. But in this case where there's no need for two calls, you see the content is pretty long. I need to figure out where it ends, right? So I have I have reasoning here already, reasoning details. Okay. Um, okay, so yes, so this is where it ends actually. It's not that long. Um, it ends here. Content. Okay, it ends. You have a great smile, blah blah blah. So it ends here, right? Refusal is none, role is assistant, annotation, function call. So you see function call is none. Function call is actually an old API, but it's still there just for backward compatibility. But two calls, you can see is none. So two calls is none. So this is how you detect that, okay, in this case, it did not need any two calls. It is able to answer the entire question without any two calls. Okay. So that's very important to note. So after the two calls, of course, like we did before, you will now have to call the function. So this is basically the same thing as what we did before, right? You have this function name, and argument. Then, okay, I have kind of polluted this whole thing by doing another this. Okay, I haven't. The message is still the message I have is still the one that had two calls. I didn't overwrite it. This one was just me doing another query. So message is still there. So for the AI API or SDK or pattern, you will now do another query. Same thing. Chat completions create the same thing that we did. Specify the same model name, right? Then you stack up the whole history of everything we have done. So you specify messages. You still specify the first query that we asked, the first question that we asked before, which was is still the same one, right? We still keep it. So this is the thing you have to know, that we need to maintain the history of conversation. That's basically what we're doing. So this one is the history of conversation. This message is the reply from the LLM, what we call the assistant. So that's why if you look at this, you will see that we start from the message, which is this message. We are just plugging that message back in. And you also see that the message, you see it has a role of assistant, right? So that's one way you can also create it. So this is telling LLM that, okay, this was its own answer to this first question. So here the role is user. But for this one, this message, the role is assistant. You can see it here. Role is assistant. So we just plug that back in. And then we now plug in the next one. The role, you can see the role is function. So this is telling the LLM that this is a function call. And this is the name of the function. And this content is the response, the result of the function call. Remember, I did the results here by still using the function implementation, the function registry. I pull the function using the function name, and then I pass in the argument, I spread out the arguments. And I'm now I run that function call, I get the result, and I plug this result back. But of course, I have to JSON encode it first. JSON dumps in Python is the same as JSON encode. It encodes it back into JSON string, and I send it as part of this third one. So with this entire messages, the LLM knows that, okay, this is part of the conversation string, and I am getting the result of a function call that I was asking for. I'm getting it back. In the events that the function call or two call requests were multiple, not just one, you would stack multiple of this, right? So after this, I would do the next one for the next function call that was requested, and so on and so forth. So with this, I send it back to the LLM, and the LLM is able to complete the request and tell me this. And if you actually go back to this follow-up, which is a follow-up choice zero message, you will see that there is no tools, there's no tool request. If you go here, it gives a content response. If I once content is not empty, right, it's going to be likely that tool call will be none. If tool call is not empty, it's going to be likely that content is empty. So contents and toCall can never both be empty, and they can never both contain stuff. Because if toCalls contain stuff, that means content should be empty. That means the LLM has not finished what it was doing. So with this, we have completed the whole sequence, and we can end it there and say, for this one, I've gotten what I needed. So that is with OpenAI. So I also did another quick one. So I'll do this quickly. This one is using Google. Google is so powerful that they even made it so much simpler. There are actually two different ways, but I could still do this with Google Gen AI. So this is just as um, an activity. So here is get weather. I have a get weather function that will give you weather in an area. Then this is a function registry, right? So I create a function registry. I also create a weather, a tool definition, a schema, right? For Gen AI, this is how its own schema is. It's not exactly the OpenAI tool schema. You have to specify these function declarations, and then you specify the list of functions. So here I only specify one function that I defined, which is the name is get weather, description get current weather, parameters, type object with uppercase, properties, location. So this is the property. This is actually a parameter. One of the parameter is location. The type is string, required location. So you can see that here it's slightly different from the OpenAI standard, but I still define it as a tool. So I now call the Gemini flashlight, which is a free, and I ask it to generate content. I use a config. So remember that I did this before the other time. I used config system information for the system prompt. But here I don't need to push in the system prompt. I just specify that there's a tool or a list of tools, and I pass in this. Tools always has to be a list. So I had already defined the weather tool, right? I could define a bunch of other tools. Then the contents is the actual query. Is it raining in Paris, right? So now with this, right, I now check. So remember, you always have to detect whether the LLM needs a function call. So this is how we detect it with Gemini, right? You use content path 0. It could be multiple paths, right? If the paths are many, you have to look through all the paths and still check if there's a function call. If function call exists, right, that means there's a need for a function call. And that function call actually contains the name of the function that should be called. It contains the metadata, so you get the name of the function from there, and you also get the arguments of the function. But if this is not existing, right? If it is none or empty or null, that means it is a standard text response. So again, this is detecting whether there is a function call needed. So in this case, it's a function call because the question is it raining in Paris? And we have defined that weather tool. So of course, raining has to do with weather. So it knows. So it actually tells you, yes, that the function call is needed, and the function that is requested is get weather. And the arguments, it actually correctly gives you the location is Paris, which we have here. So with that, you can then run your function call because we have the function implementation here. I pass this in. And because I'm doing a random thing, right? It's telling me Sunny. It's basically random. So it's going to give you anything, right? So this Sunny is not the same one that will come in here, but I'm just checking here. So it gives me Sunny. But this is now where I pull that weather, right? This is basically a duplication of this, right? So it will get a random weather thing and it's going to pass that in. So again, just like with the OpenAI, you can see that here, first of all, I specify the tools as before, right? But I also specify in contents, I need to specify the whole history of conversation. The first one, right, where the role is user and the parts, the actual query. Then the second one, we just pull the response again from this one is response candidate zero the content, which is the AI assistant. So if you look at this content like I did before, you see that the role is also assistant, meaning that it is the response from the LLM. So I stack that one in, and then the third one, I stack it in. Now in Gemini, Google SDK, they don't have a role called function. So I still need to pass this in as a user because the tool doesn't have a function role, we still pass it as a user role. But in here, in the part of it, I at least need to tell it that it is a function response. I need to tell it that it's a function response. And then I specify that this name, you may ask me, okay, does this have a schema or can I put anything? Well, go with this schema if you're using Gemini, right? So I specify the name of the function and I also specify the response, which was this actual call to the function. So with this, it will now display the response. I display the weather so that I know which weather was passed in and the response. So if I run this now, of course it was cloudy before, but now because it is random, it says it's rainy. No, it is not raining in Paris. It is currently raining. So this is another case of madness. But that's because the LLM does not know that raining and rainy mean the same thing. So we will need to think about how to solve that particular problem. It's interesting that it does it because if I run it again, thank God there's a recording. This time it will, okay, so what do we have now? Model is overloaded. Please try again later. Well, that's too bad. Let's try Flash. I think I've exceeded my quota on Flash even. I don't think I'll get anything from Flash. Oh yeah, I did get anything so rainy. Yes, it is raining in Paris. So Flash is smart. Can you see now? Flashlight was telling me it's not raining. It is raining. It's not raining. But Flash, so that's why sometimes small models are not very smart, right? This is a larger model. Flashlight is what I used before, and it couldn't differentiate between rainy and raining. It's a small model, but this is a larger model, and it actually tells you, yes, it is raining in Paris because you told it it's raining. So, um, now, I want to show this one. This is pretty interesting. With Google Gen AI, you could actually just pass the tools, the function directly, instead of doing a function schema, right? This is a shortcut, really neat one. I'm going to use flashlight for my hand before. So in this case, what you can see what I did. What I did here was I just passed the function name directly. I passed the function directly. I did not do any function metadata, function schema, or even a function registry. I just directly pass the function. So what happens in this case, Gemini is able to generate all of those things directly. It generates the function, it generates the function schema. But the more nifty thing is that I don't need to do a secondary call. I don't need to do a follow-up call. It actually does that by itself. So it's going to call this function and it's giving me 25.5 degrees Celsius because the function I passed was get current temperature, right? Which actually gives you temperature, not the weather. But let me add the weather because I also have a weather function here, which is this get weather, which I had defined before. So if I now add get weather, so you see how it's able to now, I didn't give it get weather, I gave it temperature. So it couldn't find a weather function, but it used a temperature function. And the question is, what is the weather in London? It's able to say the current temperature in London. But now I have get weather. So let's see whether it will figure out that, okay, it will get better stuff from weather rather than using temperature. So let me run this now. Um, you exceeded my quota. So I have flashlight. I have to go back to flashlight. Flash has, I have ended. I just got only a single one. Right, model is overloaded. Okay, so I will not have the pleasure of showing you what would have happened with that. Maybe I'll go look for if there's another free model that I can get from Google Gemini. But for now, that is the end for it. So anyway, I'll share this so we can try that out. Now, LangChain is the killer that does this, but I'm not going to do LangChain today because we will need to, first of all, we can do this with LangChain. LangChain allows you to define a tool directly. You basically create a function and use this tool annotation. And this is available both in Python and in JavaScript. You use the annotation to say it's a tool, and that's it. And you call this. But there are a bunch of things we need to learn around LangChain first before we'll be able to use LangChain. So we'll get to that. So that's how you do tooling. Now let's go back to the remaining slides so we can conclude. Okay. So in the process of doing functions, we've also kind of done tools. So you can see that a function is a specific type of tool, but tools are more encompassing. It's not just functions. There are other things you can do, right? And maybe when we come back, we will look at how we can do tools. Um, for tools, you can call APIs, right? You can call, you can make queries into the database. You can you can do a whole lot of things. So tools are really very powerful, right? So for a tool invocation, it's more or less going to follow what we just did because a function is a tool, so it's the same thing, right? So first of all, the user has an intent, a question, a task, right? And you can then send this. The LLM will decide, like we have seen, whether it can answer by itself without a tool call or whether it needs to do a tool call. If it needs to do a tool call, the response it's going to give to you is going to include the tools that need to be called and the parameters and everything. Then um, for yeah, this is the third part, what I just said, right? If it needs a tool call, it will select the function or the tool. It will generate the structured arguments. So with tools like the tool part of OpenAI or Gemini, when you specify a tool, you don't need to do a system prompt to say, oh, okay, do this, send it in JSON, follow this rule, all of that. Not that it doesn't, it's not done. The SDK actually does all that. And I think it's better you let the SDK do that because the people that are writing this SDK, the Googles, the Anthropics, the OpenAIs, and the rest of them, as they are fine-tuning and training their models, they also know how to fine-tune those prompts so that those prompts will do a better job than you. So using the tools um, facility or the tools capability in the SDK is, I think, much better because you get the best out of it. And like I just showed you, the last one, the Google Gemini tool will basically even chain everything for you. So you don't need to call do subsequent calls. It just chains everything for you and gives you the final result. So you only need to do one single API call, right? Or one single call with the SDK. So that's this. Then the tool execution, it's you that will run the tool or your app that will run the tool. It's not going to run at the back end or sorry, at the API end or everything. If there are external systems or external API calls to be done, it's still going to be done from your application. So you, the writer of the application or the developer of the application that is using the AI capability, all of that will run in your application. Then observation, yes, the tool result is returned to the LLM like we have seen. And then the final response, the LLM will synthesize all of that and send the final thing. So this is basically what we just did. But the key inside there is that the LLM will never execute the code. The LLM will tell you what code needs to be executed and give you all the parameters. Then it is your application that will execute the code, whether it's a backend application or a front-end application or a mobile application. It is still your code, your application that will run the code or execute the code. The LLM only decides structures, and then when you have executed the code, the result from it, you send it back to the LLM. It will reinterpret the result. So this whole tool system now is kind of a new pattern of development where you separate concerns, what we call separation of concerns, where the LLM does the reasoning. So LLM becomes a reasoning engine, like I said earlier. It reasons about what needs to be done. It reasons about what tools it needs. It reasons about the parameters and the metadata that needs to be passed around. But it's your system, your application, your back end, your front end, your mobile app that is going to execute those two calls and then send the response back. So that's separation of concerns. That allows you to focus on hardening because take note, all of this AI stuff will come with its own dangers and exposures. Right now, there are vulnerabilities that people will take. If you are not careful how you write your code, somebody can do prompt injection and take over your back end or your front end or even hack your mobile app. So you need to be careful about all those things. But separation of concern is one of the ways. So you focus on hardening the execution side, because execution side is the most critical side of it. And then let the LLM do the reasoning. Okay. So I already talked about error handling in the other one, right? So there's what we call retries for reliability. So um LLMs can hallucinate, or even like what just happened to me now. Your your API rate limits can kick in, right? Your API key can expire, right? Anything can happen, and you now get response that doesn't fit into the schema. So in that kind of situation, how do you need to build a reliable app? The fact that you have brought AI enablement, you've enabled your app to be smart by bringing AI, does not mean that your app should become unreliable or weak, or what's the word? Flaky or fragile. So you have to do error handling, you have to do retries and reliability. So let's talk about that. The common failure modes that you could have: invalid or missing arguments. Remember, it's the LLM that is generating the arguments for you. It could give you invalid arguments, it could give you wrong typing, it could give you incomplete arguments. So you need to be able to handle that. The tool itself, as you're executing it, you could have errors, right? Either from the invalid or missing arguments, or just failures like timeout, especially if it's an API call, API failures, right? And other kinds of things. How do you handle such situations? You could have partial or inconsistent results from your tools. You could even have unexpected results. You've planned everything very well, you've done everything, and then some funny response comes back. How do you ring fence all of that? How do you protect and maintain this thing? So you could have partial inconsistent results. You could even have hallucinated function usage. So LLMs hallucinate. It will just come up with one useless thing. How do you handle that? That's why I said it's better to use a function registry than using things like function exist, because your LLM could just generate one function that will wipe out all your code or something, right? Or crash your system. So those are some of the failure modes. There are more than this, right? So you look at some of the strategies that you would use to handle your errors. Make sure you validate the input before you pass it into your function. One of the best ways for validation, of course, is type checking. Okay. But other things you could do is range checking, right? Like numbers are within a range, they're not negative. If you are looking for integers, check whether they're below zero, or overflows, numerical overflows higher than the maximum number or lower than the minimum number, and things like that. So all that kind of input validation. In fact, basically just take your LLM as a user that is crazy and wants to crash your system. Do not trust anything from the LLM. Validate before execution. Then at the schema level, the schema you're sending to the LLM, apply constraints. You can even say things like, oh, this number should not be more than this or less than this, if you are sure that that constraint is valid in every situation, right? Then graceful failure responses. If there is a failure, you need to have a graceful, response, or a graceful recovery, right? Sometimes that graceful recovery, we'll talk about that when we get to retry patterns. You can even tell the LLM, this is what happened. You need to do again, right? Then the tool result itself, you need to do sanity checks that your result from your tool is not out of range or is not wrong, and all of that before you send it to the LLM. Then we have what we call retry patterns. Retry patterns is to increase the reliability of your app so that your app doesn't just fail the first time. It can try again and try again and try again. So one of the things is you need to have a deterministic number of retries. Deterministic means a fixed number, not a random number, right? So you could say, okay, try for 20 times and then stop, or try for 5 times. And if it still doesn't work, then you can stop with an error, right? That helps with what we call transient failure. So for example, timeout, or if the API call, if the API is overloaded, right? You try again, maybe the third time it goes through. So you could say, okay, try 5 times or try 10 times. So you have to do that retries for transient failures. That will increase reliability and robustness. Then limited retry counts, what I just said. You cannot try ad infinitum, because that means the app will just hang and you keep retrying and never stops. So you have to limit it. The other reason why you have to limit it is because while you are retrying on this API side, Remember, you may be having rate limits, so you don't have that. Then we have what we call backup strategy. A backup strategy is a situation where if you retry too often, you may get blocked by some APIs or blacklisted. So you try more times, you increase the interval between retries, so you don't end up being your retrial attempts do not get interpreted as a DDoS. You know what is a DDoS? It's a distributed denial of service attack. Basically, it's a kind of cyber attack where you want to overload a server by sending it too many requests that it gets overloaded, it gets flooded. That's a denial of service attack, a DOS. A distributed one is the one where the attack is from multiple different coordinated, sources or a botnet. So there are a lot of these API endpoints and servers that have algorithms that try to detect that ahead of time, and they'll blacklist any IP address that is sending too many requests at a time. So that's where backup strategy comes up. If you are retrying every second or every millisecond, they can block you. So what you do is you retry. If you retry, you increase the interval. The next retry, if it fails again, you increase the interval even further. That's a backup. There are multiple backup strategies, but that's the idea, so that you don't get blacklisted, for that. Explicit tool fail feedback to the LLM. That's what I just said. So when LLM fails, it's good to tell the LLM the tool has failed, and even give the error message. If the error message does not contain private data or critical data that you may not want to share or something. But if it is a hosted on-premise hosted LLM, well, you can pass some data. So those are some of the decisions. How much data do you send back to the LLM? But it's good to tell the LLM that it has failed, so the LLM can look for a fallback strategy. Sometimes it might be a case where, okay, try another tool, right? Or even something like, okay, let me just tell the user that, look for a story or something like that. So those are things to consider. This retry pattern will really improve the robustness and reliability of your application. Then agent-specific consideration. So for agents, which we have not gone into agents yet, agents should be able to observe failure. They should be able to decide whether to retry or not. And they can choose alternative tools or strategies like I just mentioned. So this is the things that you need to think about. Now, I want to end by talking about external connections. And so right now we've talked about tools, right? We've talked about functions and tools. The thing is this, the question you need to ask yourself is, for let's say you have API endpoints, right, that have certain capabilities. Are you going to end up writing tools all the time for every single thing, right? Does it make sense? Is it scalable? What what of API that already exists, right? Um, so people sat down and thought about this and said, okay, if we want AI and LLMs to become really smart, they should be able to access anything that is available and accessible, right? Because right now the problem is that LLMs only know what they were trained on. We've talked about this already. They cannot see live data, they cannot perform real actions, blah, blah, blah. They cannot check today's stock price, they cannot read your database, they can't send emails. So the solution is to connect LLMs to data, APIs, and actions. We've done that already. And these are the three things that you connect, right? You have external data, you have databases, whether it's SQL, NoSQL, whether it's what do you call it, relational or non-relational, whether it's structured or unstructured, whatever it is. You have files, PDFs, docs, logs, all kinds of things are stored in so many different places. And you have knowledge bases, RAGs, entire RAGs, like what we built, that you want to connect your LLM to. So even though the RAG itself is an LLM, but let's say somebody else built a RAG and you want to use their RAG, right? Are you going to go and start uploading all their documents again in your own RAG? Or you want to be able to query that RAG? You want your own LLM to query that RAG and get information, right? So these external data are the things that give the model facts and information it doesn't already know. That's the first thing you want to connect your LLM to. The second one is API, like we talked about tooling. REST API, GraphQL APIs, internal service in your on-premise company business, third-party services, payment, maps, CRM. So you want your LLM to be able to query systems and get real-time info. And then the third thing is actions, like we talked about, functions, tools, but those are actions within your app, within your application. How about outside your application? You want your LLM or your application to be able to access those things, creating records, update systems, trigger workflows. So this let the model do things. Are you, as a single person, going to write all of those connections? No, it doesn't make sense. It's not scalable. So a lot of people have thought about it and come up with ways to allow or to, yes, to allow reusability of the tools that other people have written, so that you don't need to write those tools yourself. You only need to write the tools that are specific to your own business model. For example, weather, if you want to get weather, why do I need to do that? Why don't I just connect my LLM to the tool? Obviously, somebody somewhere has written a tool for weather, querying the current weather or temperature. So why do I need to write that tool? Why don't I just, you know? So we now came up with this thing we call MCP. MCP is Model Context Protocol. It is just a standard that was defined. This was defined by Anthropic. Anthropic are the guys that own Cloud and so on. They came up with this as a way to allow LLMs to discover tools that already exist and connect to them so they can reuse tools. So basically, MCP allows reusability of tools rather than always writing from scratch, especially reusability of other people's tools. So MCP is like a USB connector, USB-C for AI models. It allows the AI model to connect to identify and discover what tools exist and to use those tools as and at when necessary. So what are the things that MCP is standardizing? First of all, it standardizes how tools are described. It standardizes how the models will call those tools, and it also standardizes how the results from the tool calls are returned back. So MCP allows a, a many-to-many relationship between models and tools. It means that one model can utilize multiple tools, as we can see here. And it also allows that if I write a tool, multiple models can use it, right, from anywhere. In fact, there's something we call MCP server. If you write an MCP server and put it out there on the web, then it is possible for any large language model to connect to your MCP server and have access to the tools that are available that you have defined and use those tools if needed. So that you don't need to be writing custom glue code, because if not, what we'll be doing is writing custom glue code, writing API extensions or connections for every LLM. But by defining a single protocol or standard that allows every LLM to be able to connect to every tool, right? It simplifies things. So this is now what will result in the explosion of capability of LLMs and LLMs being able to do a lot of stuff. So let's look a little bit at what this MCP it entails. The MCP is made up of four main components, right? The first one is the model itself, which is the LLM, whether it's a ChatGPT, Claude, whatever, whoever, right? And just like what we talked about, the LLM's job is to reason about what it needs. So it decides what it needs in order to be able to solve the task that is given to it, right? Then you have an MCP server. An MCP server is basically an endpoint that you write. It doesn't matter which programming language or what, you can write it with Node.js, you can write it with, Fast API, you can write it with, Golang, anything. But it will expose the tools that you have built in a standard format. So just like think about it like the open API JSON that we use for Swagger, So as or even a GraphQL standard. So there's a standard that you follow, right? You write your tools, you expose your tools, you have metadata that defines the tools that you have on your MCP server, right? It also handles things like authentication, security, and execution to make sure that the wrong people don't have access to your tools, especially if you want to put a paywall on your tool so that people pay and all of that, right? So API keys and all that kind of stuff. So that's the MCP server. Then the third thing, of course, is the tools itself, which is running inside the MCP server, right? But sometimes the tools may not even run the MCP server. The MCP server is just a metadata server that the LLM, you know, contacts to get information. So these tools could run elsewhere, right? But they could also run in the MCP server. So the tools are just functions that you define that will run bash scripts, endpoints, APIs, right? We've seen all of them, examples of it here. Get customer by ID, create invoice, fetch, and all of that. Then you have the host application. The host application is basically the app that will connect the model to the MCP server, right? And in most cases, it's the app that you are writing, right? So if it's a chat app or an ID or an agent, and a workflow engine, whatever it is, right? So the whole idea is you connect the LLM to the MCP server, and the rest is between the two of them. So this drawing kind of gives us what would happen if there was no MCP. You have three LLMs here, and you have multiple data sources that the LLMs can pull data from. And you see that without MCP, each of the LLM has to make an individual connection, which is a lot of code that you may have to write for this LLM to pull data from here, or to pull data from here, or even writing a separate tool for each. And each LLM does that. So you look at how much work needs to be done here. But with an MCP server will pull the data from each of these and keep the information, the metadata, and keep the information. And the LLMs will contact the MCP server and get the available tools. And this LLM is going to get all these four available tools, not just one. Each of them will get all four available tools, so that when they need to use those tools, they will now make a request to this MCP server with a tool called request. And then the MCP server will now figure out which of these tools, or which of these providers of tool services it needs to call, or it needs to send that tool call to get whatever information it gets. And once it gets it, it will send it back to the LLM. So that's basically how it works, right? So the model context protocol, it was introduced by Anthropic, the owners of Claude. It defines a standardized interface for supplying structured real-time context to LLMs and lets you call APIs as well as access files, database rules, and some other things like that. So an MCP client, which will run alongside with the LLM will normally use the MCP client to pull the data. You have multiple MCP servers, and that's the thing. There can be multiple MCP servers using MCP protocol. Each server connects to a tool or multiple tools, right? And gets, it's able to execute what it needs to execute. And then the response can go back to the MCP client, which sends it to the LLM. So the end-to-end flow of this whole thing is, if a user asks something like create an invoice for customer 1023, right? First of all, you send this to the LLM. The LLM understands the request, right? It then figures out which MCP tool that it needs to carry out this request. It selects it, and then it sends that, it tells the MCP server or through the MCP client, right? This is the tool I need, and these are the parameters, right? The MCP server will now identify which API provides, or which tool API provides that, and calls it. The API will perform that action, right? And send the result back to the MCP server, and then the MCP server sends it back to the model. And then when the model gets this result, it fits it back into the context, and then it uses that information to do what needs to be done. This is the full this thing. So this is kind of graphic, right? Um, I think I've kind of talked about this. I have a whole Jupyter notebook on MCP, which because we're out of time, I will not look at it here, but next, well, I would like to, maybe I'll just share it, right? So you can look at it. But MCP is actually a protocol. It defines how the tools are described, how a model discovers those tools, how a model invokes those tools, and how the results are returned back to the model. So Basically, this is kind of same thing that we've seen already. You have an MCP host, you have MCP client, you have the LLM running there, and whatever it needs, okay, whatever the LLM needs, it channels it through the MCP client. The MCP client takes it to the server. So the client is just a piece of SDK that allows you to connect to the MCP server with all the requests. The MCP server will now figure out which tool provides that service, call it, and get the result and send it back. And this is all designed to be scalable so that at large scale, you have distributed workloads and you don't get bottlenecks, or you don't get situation where the MCP server can get overwhelmed by too many requests, because this is really what will happen, right? And it's able to handle all of that. So those are the key components. You have MCP client, it has notifications, sampling, you have transport layers, either TCP/IP and other, protocols. It goes to the MCP server. MCP server goes to the tool APIs or the tools. It does the request and comes back. So this is basically just repeating the same thing. So let's just look at the core mechanics. So step one is the tool exposure or tool registration. An MCP server exposes a list of tools. Each tool has to include the name. So remember when we're talking about the metadata for functions of our tools, it's the same thing. You have to have the name of the tool, the description, what it does, the input schema, which is the shape of the data that should come, and the data types, and then the output schema, which is what the tool return back. So typically this data comes from the tool, or sometimes the tool itself may not be able to provide, but because the truth of the matter is you can write an MCP server for an API that is not yours. And people have done that. So sometimes it can come from the API server, but sometimes you could say, okay, these people don't have the time to write an MCP, metadata. So let me just sit down and do metadata and create an MCP server. So someone can actually write an MCP server for a service that is not provided by them. And, but LLMs will use it and channel their requests. So when it happens, you now call that API. Your own MCP server that you wrote will call that API. So this is basically what we have seen already: function, signature, and documentation. Then context injection. So the host application will send two definitions to the model, right? So the tools become part of the model's context, which we have already seen. So the model now knows what tools exist, when they should be used, what inputs they require, which we have already seen. So the model is not executing the code, it's reasoning about the tools. And then after that, the model will reason and select which tools. When it receives a user request, it will decide whether it can answer by itself or whether it needs to call a tool. If a tool is needed, then the model will output a structured tool call. This structured tool call has to follow the standardized MCP schema. So just like we use the OpenAI schema and all of that, so MCP has a standardized schema, and it's going to be deterministic, JSON format or YAML format, whatever format it is. And then the host application, which typically will run the MCP client, is going to take that structured data from the LLM, and then it will it detects the tool call by checking whether the LLM wants a tool call or not, like we have seen. And then it forwards the request to the MCP server. Then the MCP server will validate the inputs. It will execute the actual function call either by doing it internally or sending an API call to the API that provides that service. And then it will handle the auth, even the retries. Remember, we talked about retries and so on for reliability, errors, and everything. So the model will never directly touch the infrastructure. So after tool invocation, the result is sent back, like we said. Again, true from the API, it goes to the MCP server. And then from the MCP server, it goes back to the MCP client, which is in the same host as the LLM. And that information goes back into the LLM. And the LLM will now update its context with the result from that tool call. It becomes a new context. The model is able to now interpret the output and decide the next steps. The next step could also be that, okay, it still needs another tool call. So if it needs another tool call, it will still follow the same channel. But if it gets all it needs, it will then respond with natural language. So that is what allows multi-step reasoning and chaining. The main thing is that LLM reasons about it. It gets a result of a tool call. The result of a tool call may need another tool call. And even that may need another tool call. So it just continues like that, multi-step. So at the end of the day, MCP allows us to separate concerns. The model does the reasoning. The MCP does the interfacing while the tools do the execution. So remember, when we're just doing function calls and tool calls that you write by yourself, there was no MCP. So in a way, the tool was doing both the interfacing and the execution, or your code, your glue code. In fact, it's not the tool, it was your glue code that does, but sometimes the glue code may also have the function call, right? But in this case, we have separated it out. So MCP just handles only interfacing. The reason for this is so you can scale up the principles of um, um, operating at scale, right? If the amount of MCP calls is so high, then you scale up the MCP servers, right? While the tools may be, in fact, sometimes there might be some tools that you can even cache the results. For example, if you say get the weather report, you can cache weather report for 30 minutes or 1 hour. So if you have 1,000 API calls, the API will keep returning the cached version, right? Even though weather shouldn't be cached for 1 hour, maybe 20 minutes, maybe 5 minutes, but that's enough, right? To improve performance. So in this case, the MCP will keep getting more traffic than the API endpoint is getting. So you can say, okay, I want to scale up my MCP server and increase the number of Kubernetes, what do you call it? Kubernetes um, pods, that are running it and all of that. So that's the benefit of separation of concerns. Then safety by design, there's no direct access by the model, right? And then you have strict input-output schemas. You have a controlled execution layer. Interoperability, the same MCP tool can work with different models. The same MCP server can connect to multiple tools, right? A tool can connect to multiple MCP servers. A single MCP server can service multiple LLMs. A single LLM can connect to multiple MCP servers. So you just have like um, scaling, horizontal scaling, right? As well as vertical scaling. You can have horizontal scaling. So that is the summary. Let's see. I just want to give us a preview of MCP, how the MCP looks like. But I think we'll delve into it in more detail later on. Are there any questions? This is basically if you look at this is kind of step by step of how you would connect to an MCP server, right? Um, just like what we did, basically. So you have an MCP tool definition, which is not any different from a normal tool definition. It's the same thing, basically. It's just that maybe the specific details may be different. But the main thing is this, right? In the MCP server may actually implement the tool, the action, right? Or it may just know how to access it, right? So you have a situation where you have get weather, for example, and tools, then you have handle to call. So the main thing in an MCP server is this handler, where if the LLM says, I want this tool, it will now, call handle to call. This handle to call may call out to an API, right? Or may run the to call locally, right? And then the main thing is the MCP server has endpoints that the MCP client, which is kind of in the same host as the LLM or the app that you are using the LLM for. May not be not in the same host as LLM. LLM is at the is in a different thing, but you have an application. In that your application, you will have an MCP client, right? And your MCP client is the one that will call the MCP server and discover all the tools that are available, right? So when you now want to make a call to the LLM, you pull the tools from the MCP client, you put it in your LLM call, and you send it to the LLM, right? And that is the host. So this is an example of it, right? these tools, we are just saying here, tools is this. But these tools is not you that will define it, right? You will get it by calling the MCP server using the client SDK, right? And then you can then just send a chat to your LLM like we just did and specify the tools here. So the only difference between this and what we are doing is that instead of you providing the tools, you can instead of you manually defining the list of tools here, you will call an MCP server using MCP client to pull, or you can even call multiple MCP servers to get a list of all the tools are available. And then you pass those tools whenever you are calling the LLM endpoint, you pass all the tools, right? And once that is done, the LLM will emit MCP2 call. You will now take that 2 call and still send it to the MCP server, right? This function kind of encapsulates that. And the MCP server, you don't need to know what the MCP server is going to do or where it's going to call the API or whatever. It's just going to handle that 2 call and then give you the response. And this is the response. And then when you get this response, you now inject it into your secondary or follow-up call to the LLM. And with that, you get your final answer. So this is basically the same as what we just did. The only difference is that you are not going to generate your 2 calls. You are rather going to call the MCP server for a list of tools. And then when the 2 call comes from the LLM, you are going to channel it through the MCP server, right? Now, having said that, there's something I want to talk about. And that's why I started this whole thing at the beginning by showing you that the list of tools, remember, is part of the prompt, the system prompt that is sent back to the LLM. So if you call an MCP server and it gives you 1,000 tool calls, 1,000 tools, right? Definition of tools, a definition of 1,000 tools with all of the metadata, it is going to add to your token count. So remember, your LLM has a limited context window. The context window you will actually have remaining for your query is influenced by the size of the tool stack or the size of the list of tools. So sometimes it may not be effective for you to pack all the tools that are available and send it to your LLM. Sometimes it might make sense for you to still look at the list of tools and to determine which one is relevant to the specific query or prompt that is going to the LLM. That requires an added layer where you can do, okay, tool filtering, right? To know, okay, maybe that one will use metadata or tags to know, okay, if you're asking about weather, if the user is asking about weather, should I give them tools about mathematical computation? You understand? Should I tell the LLM that, oh, here's a tool that will calculate the square root of 9 to the 10th, decimal place? Does the LLM need that for weather? Okay. So this is something to think about, right? Um, you are not at liberty, let me say, you don't have the latitude to just pack all the tools in the world and send it to your LLM. You might pack too many tools and your actual context window will reduce to just 20 tokens. And then what will the LLM use to respond to you? Or what will you even use? It might even truncate your listing. So this is a very key consideration. So with that, I want to end. There is a question here. Between the main prompt that needs to call a function and the follow-up prompt, if we make another unrelated element, will it still maintain the context? So remember, the context, it is you that is generating the context. You are basically just creating a list of all the previous conversations you've had. So you can still make another, the LLM on its own, if you did not send all of that, it doesn't have any context. So if you make another unrelated LLM call, it will not affect anything unless you take the result of that unrelated call and still add it into your list of context that you are sending. That's the only time that becomes an issue. Okay, so I hope that answers that question. Can you use the LLM to reduce the tools to what you need? Yes. Interestingly, that's another interesting approach where if the number of tools are so much, you can actually have a preliminary LLM call where you say, okay, here's a list of tools and here's a query. Can you tell me which tools really are relevant. In that case, you probably don't need to send the entire metadata of these tools. You can just send a description. That way you can have a smaller window. But that LLM helps you to even fine tune. You see, that's why LLMs are so powerful. They can solve their own problems. In fact, you can solve any problem with LLM. So take a tool, call MCP server, take the list of, you can call 1 million MCP servers, get the list of all the tools from them. Then do a map and pull only the description of the tools, right? And then send that with the user query to an LLM and even tell the LLM, okay, tell me which of these tools that I need for this query. So it is dynamic. The LLM will come back and say, okay, use this one, use this one. You now filter it based on that. And then you send only those tools for the substantive query call. So it is very interesting. I'll end it at this point because I am way over my time. But I hope you enjoyed the class. If there are no further questions, I'll end the recording at this point. David, go ahead.
Okay, good evening, sir.
Yes.
Uh, so basically, my question is just because I mean we have most of us have tried, working with these APIs and SDKs, but just that most of the time there are some inference that we want to run, and at some point our token don't finish.
Well,
And it's crazy.
yeah.
So I want to know, is there like any way whereby we can actually use this this our tokens to a like a good limit, shows that, because I mean I've tried working with Sir Daniel on what he built, a lead gen, but my own API key now, the token they finish the moment he started, doing the I think what's it called, the generation of, like, generating the what it's supposed to output, before like, it won't even get to the answer, it won't even give me a response. Before you give me a response, it has already finished. So it's like well, so I don't know, like, is there a way like to actually do this?
Yeah, well, there's no way around it. The best way around it is just look for open source models. So see, this is the thing, right? There are two or three things that contribute to the cost of an LLM API call. The first one is the LLM itself, which if somebody spends millions or billions of dollars training a large language model, at least they need to get something back for it. So the LLM itself you have to pay for it. The second is the compute. So for even LLMs or models that are open source and free, you still need serious computational power, GPUs and so on, to run it, and that costs. And the cost of GPU is not really the GPU itself, it's the cost of the electricity that is burned. It's not like Nigeria, electricity is quite expensive abroad. So that contributes. That's the second thing. Then, of course, the third thing is the cost of the human manpower that it takes to just either build a code, maintain, all of that, So there's no company that will really give you everything free of charge. In fact, they have even tried, I have to be honest, to even allow us seriously. But the thing is this, um, AI is getting to a point where it needs to be, what's the word? Is it democratized or whatever? So there are companies now that give you that will give you some free compute, like Grok. But the thing is that there's no company that will give you an unlimited amount of anything. They will not give you because you are burning electricity and they're paying for it as you are making these API calls, right? So they will not give it to you for free unless you're giving them something back in return. So of course, most of these companies, they will take your data at least. All of those queries you are making, they'll use it to train their models. So it is for them, at least they get something in return. So the only thing you can do is just look for places where um, you can at least, still get free. They've tried. Gemini gives you free. Like me, that Gemini Lite that has now timed out is what I've been using to grade all of your submissions. since last year. So I know how many API calls I have made, right? Even though I'm not doing big stuff, right? Basically just running this thing. In fact, that may be why it has timed out recently because I basically automated grading and the thing was just making Gemini API calls anyhow. The second one is Open Router. Open Router actually allows you to run their compute is free in a way. I don't think I've seen any point where, well, one thing with Open Router is that you can access, you get some free models, you get some paid models. The free ones like the NVIDIA Nemotron is free. You run it, but after some time, you also get timed out. So you switch and look for the next one that is free. They always have a free one, right? Like I think recently, if I go to let's see, in Open Router. So Open Router, this Nemotron, you will see that there's this, you see this free one. This is the one that is free now, which you can use. But any other one is not free. Okay, there's a 12B, which I was using, which is free. I think there's some, I think if you even use this to a certain point, you will actually, they will even start timing you out because you have exceeded it. So that's the second thing. Now, the third thing is how can you yourself optimize your use of your tokens so that you don't overuse? I think that really has to do with asking yourself, what am I doing with this token? Should you be calling this the same LLM for everything? For example, if all you need is text generation, should I be calling a multimodal? If I got a multimodal for free, like a Gemini 2.5, should I be calling Gemini 2.5? Well, there are sometimes they tell you, okay, use a large model, it will give you everything you need, so you don't need to call it too many times. But there are some things that you say, okay, maybe I should just use a smaller model. Like this one that we just talked about. If I wanted to filter um the tools that I want to send, right? I can use a small model to do that, not the main model that I want to use. So there are different strategies. You have to come up with strategies. But I think the main thing is know which model to use for which thing. You can't just use every model for everything, right? There are models that are multimodal. There are models that are text. There are models that are image. There are models that are, audio file, like you can see here, right? And there are models that are just embedding, and there are models that are small models, that are big models. If the task that I want to do, a small model can handle it, maybe I should send a small free model versus a large free models. Small models are more likely to be free for longer than large models. Okay. So it's something you have to, over time, I think you get better at it, but you need to understand some of these principles. I hope that helps anyway. The other thing is go to different vendors. But one thing I think recently I've heard that NVIDIA is even trying to make open source free models, right? That you can even run. The only thing is that I don't know if they have clusters, like GPU clusters where you can access. But Grok is the one place that I think you can also access a bunch of models and run them for free. But even Grok, after some time, you time out. So at the end of the day, well, just take here, take here, take here, take here, take here, and join. You know that that's how you survive. But at the end of the day, right? You just at some point, I think the other thing is if you can afford to pay for some premium, this thing pay as well. So
Mm,
you encourage them to because they are giving you a lot.
I'm seeing $300. But okay, I guess I will just take your advice on that. So
Yeah.
so thinking about for the tooling that we just talked about, when this thing brought out like so many tools, then we are like doing like a search of the particular tool that will actually solve the problem. So there's something I read about what's it called, MOE, that mixture of experts. So I was thinking if that with any way like come in
Yeah,
actually.
a mixture of experts is a machine learning thing. It's not mixture of experts is basically a neural network architecture. It's an architectural thing, right? Where the okay, maybe I need to rethink that. Maybe we now have mixture of experts at the AI level where you are mixing multiple models. But what I know mixture of experts to be is the architecture. Um, there's what we call a feed-forward layer, a feed-forward network in transformers. where you can train certain parts of the network to specialize in doing certain things, right? And then at the end of the day, you will basically allow each of them to, as they specialize, when they specialize, you now pick the best specialist depending on the task, right? Right. There's something called routing, routing, which routes the tr- the logits, right? It routes the logits to specific parts of the LLM that have been specialized for specific task or specific inference, right? But that is more at the model training architecture level, not and of course inference, it happens automatically, but not the AI level. You cannot choose. But then who knows? I might be behind, so I need to go check that out. What's currently going
Okay. All right, sir. Wow.
on. Okay, thank you very much, everyone. I'm going to send a task, and the task is really going to be on tools. So go work on it. I'm going to ask you to write your own tool to do a particular thing, and then you write your LLM to be able to use that tool when a query that needs that tool is needed. Then I'm going to test it by sending queries that need those tools. So go do a bit of work on this, and we'll see how it goes. Thank you, and welcome back. We'll meet again on Friday.